sort of portal and GUIs. But there was evident that we wanted to run workflows and construct a way of not just querying, but taking data and passing it to particular application servers and run particular modeling applications if we could on another service. So, I mean, the main goals for these plugins were we want to sort of first discover what kind of services and databases are data services and application services are out there, how to query these query interfaces for both the Helio and VanVC. They have similar query interfaces, but they were different, so both these plugins had to do slightly a bit of a change. VanVC gets that what's called an XAMS data model, where Helio is the sort of the IVOA VO table data model, and I think Taverna's already has several things for VO tables initially. We want to run application codes, particular modeling that's been done in the Helio physics community, some spectroscopic particular application codes. A few of these, I think, are sort of based on IDL. Usually they're IDL-based services. And what we did with that is IVOA has a particular service standard called Universal Worker Service. And we integrated with that standard, installed a UWS interface in front of these application codes and called those services. And sometimes we wanted to have a few utility services. These may be simply converting XAMS to HTML, XAMS to some other kind of format, like one of the applications we codes had this particular SME format, so we could convert to that. So there's special utility services based on that. From Carol's talk this morning, some of these plugins, I'm realizing, I mean, it's just, you could have almost written them as a main workflow themselves. It's just, and now I'm starting to wonder, could these be converted to these components? And I think that a lot of this probably could, and it's something I think is probably worth going back and looking into. Because the only thing, it's very much how Carol's talk was, there was where there was you could have it as one workflow. It would look incredibly messy, but you can package those up as one component. It suddenly simplifies everything. And that's exactly what these plugins are sort of doing. And the next few slides are how did we reach these goals. Discovery area, they both use their own kind of registry. It's the IVOA registry. It's that International Virtual Observatory Alliance. And the main areas they want to do is specify what kind of service they are. Are they catalog service, specific application services? You can specify whether there's another registry. In general, different kind of resources. There's usually two types of registries. There's a publishing registry that you're going to be actually submitting your data, your metadata. I should note there's also the core metadata, which is your contact information, things like that about your registry. And then there's the full registries, which go about harvesting all the other publishing registries around the world. 4 key areas on the discovery is, again, these core metadata, but the main thing we wanted to get around was these, there's these capabilities where you sometimes define a standard ID that you know that they conform to a particular specification, so that you know what kind of query interface does it conform to. And that way, the plugin for itself will actually query for a specific standard ID. And then you can have these access URLs, which are actually where the service is located, and they can be, you can have 2 or 3 per mirrors. And our plugin will actually try the first one. If it's not available, it does a ping, go to the second one. That way, there's a little bit of a chance of availability between the mirrors. And the other key areas is the table metadata, such as the column metadata, help construct queries. And same way with application. Whenever we're running a particular IDL application, what are its inputs and outputs so that you know how to actually fill out that data to retrieve the output. This is sort of just a few snapshots. I could probably flip to Taverna and actually see it a little bit better. These are sort of menus that you can see in both the VanVC and Helio. And here you have some of these utility methods, so you can use consumer services for converting data. All of these particular are tap query nodes that are discovered in the registry. I've got the Chianti database or the Hydran database for VanVC. And this here is particular, sort of think of it as like all of metadata that you'd want to run on. Like there's a special atomic nuclear charge, these energy keys, an ion charge. So you actually get a quick view of what are you actually available to query on. So you just, what tends to happen is a lot of people go to actually the portal, the web GUI portal in the beginning, get a bundle of queries that they know that they're going to want to use, and then they come into the workflow Taverna and use it in that kind of fashion. This is sort of, I'm just going to quickly run through like creating the services. These are the typical input and output operations. And here we have what kind of language, sort of like a SQL, but it's actually ABQL for the IVOA type services, but in some sense it's really SQL with a few extensions to it. A reference is usually sort of like, this was a URL reference, or do you want the data to come back to Taverna? Because a lot of times you don't want the data to come back to Taverna, I just want to pass it along to another application or another service in the workflow. So this just actually constructs you a URL, and that just gets passed along. I don't bother passing it, I don't bother retrieving megabytes and megabytes of data. Well, they can if they want to, but I think most of these services tend to actually pass it along. And one key area is you can give it the direct URL, or you can give it the registry identifier. And usually the registry identifier is a little bit better. That means the plugin will actually go and look it up in the registry for the URL. Now, the handy way, the reason for this, and the advantage of this, and I think Carol mentioned it in her first talk, is after some months or years go by, people move these services around, all the time. They're not there anymore. So workflows tend to break if you end up placing in the URL. So the idea with this registry identifier is you place that in, it looks it up in the registry, and unless it's just not in the registry anymore, someone's deleted the service, which usually doesn't happen. A lot of people just move them around. There's still some kind of support. Yeah. So that is the basis between these registry identifiers. And the URL is still quite handy for local testing and things like that. People, maybe they don't have it in the registry. So just place the URL in there for local testing. This is just a sample of a few applications. Here, this is like a flare plotter. You can give it a simple date as an input. You can give it an optional time to abort in minutes. Maybe, if you think this application is running 5 minutes instead of going an hour later, something's wrong. And usually the output is either you get a unique ID for every application, and in this case, it's a flare plot PNG. It's an image itself. Here, that is from the Helio. This is from the VAN-VC that takes a temperature and an observation file. And again, you're always going to get an execution ID, and it has 2 outputs, and that is report files. Utility services, namely, like I said before, this is usually converting particular XSAM services to something else, or VO tables to something. I actually went ahead and built in a whole visual GUI called TopCat. It can be actually launched inside Taverna. It's installed as part of the plugin as well. That's an actual visual GUI and a whole other application that comes up if someone wishes to call that. I sort of mentioned a little bit of Astra Taverna, which is, I'm not involved with Astra Taverna's team, but I use it quite often in my plugin because they are based around a lot of the astronomy work. They're part of the Workflow Forever project, and they have really put a lot of work in their plugin, and it's really nice, all the different capabilities they have. Because, for example, I do a lot of things with VO tables, and they have did things where, to be quite honest, they're using a lot of the stilts libraries that are actually built inside TopCat to do things like extracting columns, cross-matching the VO tables. I think there's other coordination conversions. And then they also placed in these various VO services, so it can connect to IVOA registry to do comb searches, simple image access services, and simple spectrometry type service, or SSA kind of services, simple spectral access services. And there's this idea of these parameter description languages, which is also about around calling complicated applications, but I have to say I have no experience quite with that. I know the basics of this PDL type service, and I think that is sort of in the latest plugin release, if my memory serves me correct. This is just sort of a walk. This is sort of an example of a typical vanity seated workflow that actually called probably 3 or 4 different kind of services that are available in the plugin. Namely, you're grabbing an observation file. You're calling a simple, especially made easy application to get a particular range, and then you're actually calling a tab service, convert it to a particular format, and then actually call another kind of spectroscopy made app, IDL application. And then at the end, I call the browser up, and you see the whole report. So what are some quick conclusions to this? Most of these workflows are in my experiment, though I have to say the Helio ones needs to be sort of updated because I think they were originally done by Anya, and I should say that the Helio project, they did want to know about they did get involved with Taverna much earlier, and they, to my knowledge, have employed, I think, Donald in a certain percentage way and Anya, but I could be wrong, but I think they were all, and John Group as well. And Anya did some of our very first workflows, but this was before the plugin was ever made, and some of those are probably already failing, you know, just because they're looking at old services, locations that have been moved around. The NDC, I think, is in my experiment a little bit longer. For the, I mean, the plugin has been developed a little bit longer, and I think there's a lot more in the my experiment location. Need to learn more about this in this workshop and how to upgrade. The plugin still needs a little bit of cleanup in its maven and logging. It's a bit rubbish at the moment. I need to do a little bit more cleanup on some of the coding stuff that's in there. I should know there's not really any real funding at this moment for any plugin development effort, at least on my part. There are, I know, some proposals that are in the works that are coming up for next year, especially with, I think, some of the Europlanning area. They specifically wanted me to sort of be involved with the VandyC and Helio plugins with the Europlanning tie-in. Now, I'll probably know until early next year how those proposals are going. And find a few links to where the VandyC plugins and Helio installation guides are. I think that was, yeah, that was everything there. Thank you. Any questions?
I have some question about tables, because you said you was dealing with VO tables, and so we did in Astro Taverna, and Christian has been looking at generalizing VO table support as a general Taverna table support.
And it was a Taverna table.
Well, basically to make VO tables accessible to non-astronomers, because we already seen it. It was successfully used in.
Yeah, you still see a step further than that, because you've got VO tables that hard coded in all over the place. So you go through CSV tables and other. Some of these stilts are doing this, some of them can't, but a lot can't.
Yeah, the Stilts is a very nice library. I think that's probably what Astroturn is doing, where that was written by originally Mark Taylor, who developed Stilts and Popcat, and it's a nice API. In fact, actually, a lot of Helio query interface services is really using Stilts in the background to bring back VO tables, and you can ask it to convert to HTML, CSV, a few other things. It has a wide range of.
Does it have an API now?
What's that?
Does it actually have APIs still, or is it all just command line?
Well, it has an API to it. I'm sure our Helio query interface is not interacting with it. I don't use
It's an API, but it is not the proper one, because
I just have
some
command
of the
line.
API could be like, oh, it didn't work, system exit.
No, we don't even get command line and stuff. And in fact, a lot of Helio query interface areas, it was nice that the Stilts even allowed us to extend it a little bit, because a lot of the, one thing we didn't want to do, for example, is read from a database and just send everything at once. We stream the data back, and I think that was one of the extensions we sort of made in there, to sort of extend Stilts a little bit so that we could query row by row and start sending the data back to the VO table. It does mean sometimes the service goes down in the middle, or network goes down, and you get a half a VO table, but at least you got something coming back. So, sorry, did you have a particular question in that?
No, just that.
I have two questions. One of them is, you mentioned the querying services. So is it the intent of these services to provide, to enable like the scientists to go to do the most of the data scoping once they call the service? Because from the plugins or from the outsourced Taverna, as far as I can remember, there aren't any like filtering components or anything. So the main scoping is done when you query it, the external database, and follow-on steps is almost like expanding the data with some local computation. Would you agree with that?
Well, we don't do any, I mean, it's up to the science how they want to filter the particular data. But I do know with Helio, for example, there was a bit of a push to, for example, query on certain external catalogs, like event catalogs and feature catalogs, to sometimes drill down to what kind of data do you want. Because the problem is that when you connect to something like 150 different instruments, you just say, please give me everything for the month of March, and it starts downloading gigabytes of different data. And one of the things we were trying to push people to do is look at these event catalogs and feature catalogs to see, was your instrument even observing at that time? You know, don't just start, asking for it. But there's nothing in Helio that actually restricts you from not doing that. You can go in and say, I want all 100 instruments, and it will start downloading all that data. But we did try to, we do recommend, query these other data sets to filter down to what instrument do you actually want, what kind of time range do you want.
Okay, thank you. And second question is there any data management infrastructure that scientists use for the results that they get? Or do they locally manage the data that they get from?
There's two things. Our Helio query interfaces do have what's called a long-running query interface, so they can save the VO tables on the server itself. But and there was some notion at a time of actually allowing it to be ported over to these VO spaces. But to be honest, they're not really doing that. Usually, if there is anything, what they will do is save the VO. They might call it a long-running query to save the VO tables on the server. But what my experience is that they tend to actually download it to themselves, and they will do their own data management. Is what my experience is really telling me that tends to happen.
That sounds familiar.
I think a lot of people, the VO space is still a very nice concept, but I think a lot of people just they don't want that extra step. They sometimes want to grab at that data, and they want to sometimes have their own Perl scripts and start looking at the data themselves. They're so familiar with their own scripts that they'd rather sometimes just grab it quickly and run their own little IDL apps and Perl scripts.
And also that they know where it is then, because it's on their infrastructure, they build as if they own it,
yeah.
And it's safe because it's in their place. And
I mean, there is quite an advantage though with the long-running query interface and the fact that it is nice that you can save a workflow and I can give it to you or Donald or anybody, and they can automatically hit run, and if need be, it will download these VO tables. And if we wanted to save those VO tables for history, that's sort of a nice thing.
that's kind of analogous to Galaxy world, not different kind of galaxies in space.
Yeah.
The Galaxy system in biology, using biology, which has workflows that you exchange. And if you use the same Galaxy instance, you can just share them.
Yeah. I mean, I can even see it being quite an advantage for like PhD students and things like that, where they could actually place it in their papers for something. Here's a workflow that would automatically run and improve my paper.
It's analogous to the iPad, isn't it?
Yes, the iPad. Yeah, it's a kind of shared notebook. I'm very interested in taking stuff. Are you going to go crash and trying to replace one of your plugins with a component?
I'd like to, yeah.
On that subject, we have the same problem we have the same problem with SoFlab, because in the background, SoFlab is actually doing, every time we call a SoFlab service, it's doing that's
Yes.
right? And when the SoFlabs were taken away from the EGI, and quite a lot of them were replaced by the rest of the service, we then have to sort of figure out this single thing, what on earth do you replace it with? And you really should be able to replace it with another version of a new version of the component that just calls the recipes instead. But you can't do that.
Wait, you mean the component infrastructure one?
Yes. Yes. ideally, you should be able to have a component that is flow progressed
Yes,
instead of the server line.
Yeah.
Right, you should be able to replace yield the server line service with a new component that flow progressed instead.
yes.
But you can do that, can't you? You were saying you couldn't, I thought you were saying no, you couldn't.
Yeah, so we're confused now, Alan.
Yeah.
Are you saying that, that
Well,
if
you
you
confused me
implemented
as
this
well.
as a series of components, you would be able to, and at the moment you can't if you haven't done these components.
Yes.
There we are, years of, I was in the same year at the university, all those 35 years or something years, paid off, and worked out in it. Yes. So yes, you should be able to use components.
Yeah, so, I mean, I would like to do that. I think it's a matter of time. To be honest, it'll probably be, I don't see it till early next year.
Yeah.
So,
But it'd be very interesting to see that, because that's the reason we invented components, was you'd be able to do this switching out interchangeability aspect, and you'd be able to do the hide the dirty linen aspect.
Exactly.
Airplane that's broken.
It's a rundown airplane.
Started to do that.
No.
Of course, I left. I'll sit here. See? Now it works.
Keep it there.
Maybe it's just practiced now, I think, figuring that out, when I show up back.
It's fine.
No, it's fine. Don't touch it. It's fine.
You sure?
Isn't it working now?
No. Well, that's because if I hit play, it doesn't work.
I went to my PDF, there was something.
Is it trying to be?
So I'm just trying to change the resolution.
I had the same problem, yeah.
Maybe you should turn off mirroring. Is it mirroring? Hang on, it's doing something now. Oh, it's
Mostly just it's showing on the phone.
I was on 1,044.
I blame it on distraction on display thingy.
You were on what, sorry? 1024.
Yeah, and I did have a mirror, I had mirror
It
display.
is to do with signal, yeah, it's to do with this.
But I had to say that,
As
yeah.
you go to McDonald's, and if you've got a lot of cable, it really does correct. It is true, they weren't just bullshitting me last week, but my solution was replace the bloody cable with.
Once upon a time, rights were the only
They replaced the cable. In fact, they shipped in the time you want to exactly. That can be quite fierce. It's developed solution. Geeks, so they all kind
I'm not switching back to how it was, and show the full screen.
of. Do you have any animations?
I do, but it's fine.
Oh, no, yeah, it's the VPH one. This VPH is full of animations, because they're gorgeous. Could we put it on a, could we put it on a, Dell, looking randomly over at Alan's machine?
Okay,
The machine which is really good at these lines, so the projector.
Okay, maybe not Dell. What about,
Or did it-
your bio?
Oh!
Your bio,
What's
the talk.
The difference is that on mine,
I
there's a
know.
tendency to crash the projector.
And,
What if you just don't click the button and you just have PowerPoint in the window?
Yeah.
I'm going to say that.
Something
Otherwise,
like
just put it on the screen.
You want to?
Yay.
Hey, woo!
I've got 1 minute left. Press on.
Thank you.
Hi everyone, my name is Sashil. I work for VPH Share, and what we claim we do is research as a service. I'm not really sure that's true, but
Be careful, you're being recorded.
So what we do in Sheffield and in our project is something called in silico medicine. So essentially the idea is you can run simulations and mathematical models on clinical data and then affect healthcare, or at least try to affect healthcare. So we try to personalize our mathematical models using patient data. So first, we have large volumes of data, tremendous amount of data we can try to get our hands on, but ethics won't let us, which is good. So once we get all the ethics clearance and everything is all black and white, then we can get all this data, and then we build mathematical models. Now this is a model for circulation, so it's a 1D simulation of circulation. It's called Guyton models. And at the top right corner, there's thirst and drinking all the way up to heart rate and things. So you put all this together, and somewhere in there is your data that goes in. So how much you drink, for example, or what's your heart rate, and some numbers pop out, and then we can use that to predict. So mathematicians and big science have been trying to do this all the time, and they look at all of this, they look at all the data, and they say, no problem, we'll do it. Not an issue at all. But it's not really that. I'm sure everybody knows that. It's quite difficult. It's quite difficult to actually glue things together. We find, and that's where Taverna comes in. So what we try to do is patient-specific, multi-scale scientific workflows. So we started off with 4 projects. So the first project was a long-running project called EU Heart, which is primarily dealing with the cardiovascular workflow. So electrophysiology, mechanics, fluid dynamics, and just coupling all 3 together to try and predict heart failure. The other one is aneurysm, so cerebral aneurysm, so predicting the risk of rupture in cerebral aneurysms using blood flow and morphology. The other one was orthopedic, so again, risk of fracture. So we tried to take patient data, run some mathematical calculation, and come up with risk of fracture, risk of rupture, risk of heart attack, so on and so forth. The other one is slightly different. It's viral, looking at HIV modeling and epidemiology. So these are 4 flagship workflows. We started 4 years ago. Now we have about 20, 25 different projects using our infrastructure to build their own workflows. So all the way from oncology, again, to hypertension, vascular stenting, and musculoskeletal. So all these projects have been funded over the past few years to leverage our platform to build VPH style workflow. Now VPH is an umbrella term for physiological modeling. So trying to use clinical data and mathematics. So an example, I could have shown you this video, but I can't because it's a PDF. But the idea, if this video would have worked, is what you would have seen is you start off with images, and we do image processing to try and segment the images to generate a 3-dimensional mesh. Once we have that mesh, we can do mathematical modeling on it. So you can do fluid dynamics. In my PhD, we did electrophysiology, for example. So we do all these models and come up with numbers that users can use. So another workflow is essentially the same kind of thing. You get the image, you get the image processing done, and then you can do hemodynamics and morphology descriptions of the aneurysm to see how the shape of the aneurysm, and you can do fluid dynamics as well to predict it. So these are primarily image-based modeling. And there's also another one which we have started recently, which is taken up quite a bit because there's a lot of people interested in this, and this is called the VFR workflow. So the idea is in the coronary arteries, there's a large pressure drop, usually in stenosis. And before, what they used to do was to guide a pressure wire all the way through into your coronary artery to measure the pressure drop. We can do this virtually. So once we do a CT scan or an MRI scan, we can do this virtually, and that's the idea of this project. So this is the architecture. I'll just run through very quickly because I'm aware of the time. We've got a cloud platform and a grid platform on top of which we build all of our infrastructure. So our workflows is just the primary glue that brings together all the different computational components of our architecture. There's an underlying infrastructure stuff in there. First, we start off with knowledge management, trying to get the data from the clinical systems in a curated form, or at least partly curated form, to allow the researchers to do whatever they want. So we start with defining a patient avatar. So what is required for a workflow to run? So we try and gather all the data into a single place, single point of truth, as I call it, where if it doesn't exist there, then it doesn't exist anywhere in our infrastructure. So we try to bring all of that together. Then the clinicians can slice and dice, the researchers can slice and dice this into whatever format they want and bring it into a workflow. So we clinically start off with clinical management systems. We publish the data into RDS graphs and image data. We define a patient avatar, and the workflows at the bottom essentially just glue the things together. So they take in the patient avatars and inputs, do some processing on it, and then put it back into the patient avatar. It's almost like an electronic health record, if you can imagine that. So it's a pseudo-electronic health record. And the idea is once we have all this, we push the data back into the clinical information systems, and then they can do whatever processing they want to. Doctors can have a look at it. We have a large number of data sets in different domains, primarily image-based computing, but we also have large-scale aggregated data sets as well. So to move on very quickly, so this is essentially our architecture. I'm pretty sure we won't be able to read much of this text on the slide. It's pretty detailed and goes into little minuscule details on what each component does. And if you're interested, I can tell you more about this. The platform architecture is something that you guys might be interested in. That is one of the reasons why I'm here, to try and push the idea of execution engines and try and at least guide that process in your own development. So to see if we have aligned strategies in place. So what we like to do is to run these executions of workflows in multiple clouds, multiple grids, because our requirements are such, because some things can run in only the hospital and nowhere else. So we need things to run in different places all the time. And sometimes they are completely shut down. So when in your world, a web service is a web service, it's always switched on. In our world, web services are not switched on. It doesn't exist until you tell us to switch it on. So how does that play into your own execution models? So that's the kind of discussions I'm here for. And I think one of our developers tomorrow is going to come along and tell you more about the actual operational aspects of it. This is kind of the architecture. It would have been nice about animations, but the idea is a clinical researcher can use the VPH Shared plugin to interact with our platform right now in two different modes. You can do it through the workbench, you can do it through our own execution engine, which essentially directs Taverna server to do what it's bidding kind of thing. And then our execution engine starts up virtual machines, spins them back down again. So we've got a large platform, runs in 4 different data centers, well, 3 different data centers right now, and public cloud providers as well. So we run on Azure, Google Compute, and Amazon. So this is just a slide I've been writing down whilst you guys have been talking. So these are the kind of conversations we'd like to have. So data migration plans. You've been talking about Scuffle. We have teaching profiles. How do we convert them into Scuffle if you're going to move to Taverna 2 and back again? Because some people still maintain that they want to use Taverna 2, for example, 2.4 in their hospitals. They're not willing to upgrade because of licensing issues or whatever, not licensing, but support issues. Buckler 2 data bundle. We use Buckler files for our input data. If you're going to migrate to a data bundle, how are we going to migrate that? Is there an easy way to say, okay, all the data bundles in VPH Share, here's a command line, just run through all of them and convert them into data. We need that, otherwise this migration is not going to work as effectively. So engine support for cloud and grid, I talked about that for a bit. Platform and help with multiple surveillance. I mentioned that where you run and move in different places, but the idea is we want to have a single point of entry where you then send it off to different Taverna servers and prevent Taverna engine hooks and subscription APIs. We'd like to know in minute detail where we are at in an execution run so that we can take appropriate action. For example, in our case, when the execution happens, we do not know if the virtual machine is switched on or not, or switched off or not. So we'd like to know before the component of the execution starts, we'd like to send off that message quickly to VPH and say, switch on the virtual machine quickly so that the next bits can do the bits and move the data back and forth or whatever. So that's something that's really important to us. Checkpoint replay, I think you mentioned that today, I just noted that in. components. So we've been using components quite a bit now in Insignia, in fact, not in VPHS, but VPHS sort of influencing Insignia. Insignia is an institute in Sheffield that does in silico medicine. Are interested. Components is something that we use. We don't really have a components registry API or a server component. Now there is my experiment, but it can be a local version of it, or somehow we can start developing it. Right now it's just a large XML file, which we just load in. What about portability of components? Now, what I really mean by portability is moving between workflow engines. So if you take a component and say, oh, I want to run this in Kepler, or I want to run this in Galaxy, can you move that? Maybe you can move the workloads up, but that's a different discussion. So just the components.
On that point, Steve and I are involved in a Google group discussing that kind of area.
Oh, great. Just let us know.
You joined us well, Barbara, didn't you? That's very relevant.
We've been playing with for quite a long time.
Yeah, but it's now actually sort of
Yeah.
things are happening.
Because we had an exercise ages ago where we did Kepler Taverna
Yeah.
calling. We actually used provenance as an exchange.
It's
come up in many places to have a common kind of tool registry, right?
Yeah.
Similar to service registry, but tied to the tools.
Yeah.
Right?
Yeah. So we just like to have a components register, not the entire workflow. Because
Yeah.
workflow's already there, but my experiment.
Yeah.
So something like was there an API? Community support. Now, you guys are building the community, which is great. We need some support. So we would be developer support. Whenever we have a problem, we run to Manchester, it's like, we've got X, Y, and Z. Community as well. So similar to the Apache, whatever the Apache Foundation is doing, we need some form of community level support where communities can help each other out and to find out, oh, they've done EO tables, can we generalize that? Can we use that and be a chair for doing data table? Developer documentation, I mentioned that. Again, my experiments for dynamic websites, I think I mentioned that to Alex at some point, she's sitting there not looking at me.
You mean my experiment or
No, sorry, my mistake is biocatalog.
Biocatalog for dynamic websites. That makes more sense.
Yeah,
Okay.
sorry.
That's a relief.
My mistake. And stage key support, I think I spoke to you about this. Instead of using username and passwords, traditionally now they use stage keys for most things, and I'd like to just use that. And there's lots more. I think that they will tell you a lot more tomorrow. But that's my list, and that's the team, and that's the number of partners. Thank you.
Very good. Very good.
Any questions?
The dynamic, biocatalog for dynamic web services, that sounds quite interesting actually. I've got a word with Alex about that. Because we're kind of working at the moment in Elixir with a web service with login activity there. So Elixir is some kind of complete bear fit. I just seen a proposal that suggests we completely eliminate all the work packages in the proposal. Don't like to frighten, but I like to avoid that. So anyway, who knows what's going to happen? But there will be a registry of services because it's absolutely critical.
Yeah.
Elixir.
Okay.
That'll be interesting to bring.
Yeah.
But we're in Brian Bridget. We do work with Brian Bridges. That's politics.
I understand, but I mean, this is not about web services, but about bioinformatics software.
Yeah, but we also feed the next generation. The biocatalog feeds that registry, the tools registry. Yes, we spend a lot of time talking to Chris. In fact, Alex and Niall have done a lot of work with Christopher on that.
Okay, and all of this story, like, I had a lot.
Yeah, it's a kind of, yes, and Christopher was in the Embrace project, if you remember. So, yeah, it's all related, but there's politics there. Did you know that, by the way, that there's a hackathon to populate the biometrics service catalog.
I know that related to the question of this. In Spain, even
No, this is a hackathon where people, physically go and just.
wasn't Russell for me.
No. That was the service. That was the ontology of using art. Yeah, this is another one. I can send you the details if you're interested. Yeah, it's in Copenhagen.
Sorry.
Yeah.
Hey.
Yeah, so it's not really a Taverna question, it's more about the science part. So what's the relationship between your patient avatars and the models? Do you take the data model parameters and then use that to define an avatar?
Yeah. If I had my animation, it would make a little bit more sense. Just see if I can quickly just show you that. I'm not really sure if they play. So here we go. No. Okay. So I'll try my level best to explain that from my head. There's one thing I can do.
You can just display it as it is. Yeah, just make it bigger, but not put it in display mode.
Yeah.
That's it.
So, okay, if I take that. So, if I take this. So what happens is, a workflow says, I need demographic information, vital signs and images, or whatever it requires for it to process the data. That is what we call the patient avatar. And that is populated from the clinical information. So essentially, from the clinical information system, we just push everything into RDF. And then we say, for each workload, say, I need this list of things as my inputs. And that is the patient avatar for, let's say, cerebral aneurysms. So that's the patient avatar for cerebral aneurysms. Because this is RDF, and this is also defined in RDF, we just link the two together. So instantly, as soon as new data appears in our systems, patient avatar is automatically built. And then the user can say, oh, I've got 10 new patients now, or 300 new patients. And just say, run this on these 300 patients, essentially putting churns away on all of the patients. So the patient avatar is defined by the workflow rather than from the clinical information systems.
Okay.
So each avatar will be different.
So the final step, so if you leave up the information to parameterize the model, is there a link between the avatars and the model in the same sort of way?
Yeah.
So the models are annotated
Yeah.
RDF as well?
No. So there is no direct link between, okay, so that's the question you're really asking.
Yeah.
So there is no direct link between the model and the avatar. The developer of the workflow or the model defines the avatar
Okay.
as they go along. So if a new model requires a new parameter, you have to put that into the avatar. But as soon as they put it in, the avatar is automatically populated. Does that make sense?
Yes.
So, and because models are continuously being updated, I can see your point. There is an advantage there because you can say, well, if that is also annotated, we can just automatically create a patient avatar just by looking at all the services and then build that out automatically. Yes, that is a good point, but we haven't done that. We just try to do, let's do this first. And so, this is
like
exactly.
200 different parameters.
No, yes, but getting this, the hardest challenge was not getting the workflow developers to define this. The hardest challenge was to get them to say this is the right way to push data in.
Yeah.
And that then is, we say us and them because it is them. Their default answer is no for most things. So managing that is difficult.
Yeah.
But yeah, I can see it. That's a really good point, and I think we should think about that. Thank you. Any other questions?
I think we should put that dynamic servicing office discussion point as well.
So the catalogue, the registry hackathon, which is popular, this registry developed by Biomed Bridges and Friends, is it
You want to see it now?
on
See it?
November
Yeah?
19th.
Yeah, maybe. Yeah, let's do that.
And it's the
I mean, I won't
registry
spend a lot of time working on that.
Let's plug it in now while there's a break. Okay, so now it's Windows and HDMI. That should probably be.
You mention it, I tend to take this, caffeine, paracetamol, and codeine in my tablet, and then put ibuprofen, or you can pronounce it, on my knee directly. So I'm drugged up. Yeah. You feel better for it. I think that's energy. You're on.
That worked.
Way! Woo! It's not a map, is it though?
Yeah, I think it's because it's not.
Slowly.
I think we're,
Great. Okay, so thank you for the invitation and thank you very much for organizing this workshop. It's really great. All the ideas that you heard so far. I'm curious about the rest of tomorrow as well. My name is Yasina. Half of my time I spend in Leiden University Medical Center, but I'm also affiliated with the University of Victoria in Canada. So I work with both sides, and then we use scientific workflow mainly Taverna for our work. I should mention that I started actually with my first work. The first time I started using workflows was in the medicals in Germany. That was GWDL, completely different workflow system, and then I used Mentor, and then in the end, now we are using Taverna. So I was asked to talk a little bit about our latest application and latest development using Taverna as the peptide picker, just scientific workflow with a web service or interface for peptide selection targeted proteomics. I will also mention a little bit about our other workflows and about the development plugin for proteomics that we are working on. If there's any question, please interrupt me whenever you want, or you can ask also in the end of the presentation. So, peptide picker, it's it is in targeted proteomics. I don't know if you know about proteomics. We take samples, we try to figure the proteins. Targeted proteomics is a different approach. We take samples, you target specific proteins. We want to know the amount of these proteins in patients and in control, and then we measure that. We measure the concentration of these proteins. It's a very complex process. You use mass spec for that. One of the main steps in the beginning is to select which peptide you want to have in order to target this specific protein. It may be an easy step if we know about that protein, but we don't know if we can detect it or not. So what we're trying to do here is to harvest everything what's existing there in the net, bring this data together and try to come with a weighted list about the selected protein. And that's just like one step in the process. So before it, after it, and then after the analytical step, there's all other steps. But I will be talking, peptide picker is only this step here. And the first workflow that we developed was like this, and collect information from ecstasy, from UniProt, peptide, so a lot of other database and a lot of other web services are involved in order to make this run. What is very interesting, we talk about web services, we talk about XML. The proteomics community is not that developed yet. So that means some of these services will result in simple HTML. And then what do you do with an HTML? We developed our own processors to parse HTML and extract the information from there. So there was absolutely no other way to do it. But this is the workflow. We then show it to someone who's working mass spec or someone from proteomics. They cannot stop anything with that. So we were communicating with the Taverna team about the player, but we thought also the player would be also so complex for them. So we developed our web interface, simple thing. Put your accession number there, press submit, and then that's it. You wait a little bit, and then you get your list. It's a Java servlet. That means from the beginning when we developed it, we wanted to be possible that we use it as a service like get and as a get service from within Taverna. That means you can call this web interface or this service from Taverna and as in another workflow. So you'll be running other workflow and another workflow. So you will be running this workflow and another workflow in order to get this list. For sure, the list is like, this is the simple one, and then you can download the whole CSV, which contains all the information that we harvest from all the other databases that I showed in the beginning. This is about the usage, and as you can see, there's some usage in Canada. I didn't see it on the list what Carol showed in the beginning, but all these sites in Canada were actually sending queries to our site. We were Taverna for them, and reporting the results.
Yeah, I mean, that's one of the problems with the usage statistics. We have it in Biodome as well. When people are running workflows on the Biodome portal, then it's just running the Biodome portal, you can't tell
Where does it come from? We need to go to them directly. So if you would see our results, you would see it like it's coming only from Victoria, but it's actually from all over the world.
And this is very important if you want to get renewed funds.
Exactly.
Because you need to show the breadth of
The usage.
Yes, yes, very good.
Exactly. So that was the workflow, and then we said, okay, let's exploit it. Let's run it with big, like let's run it on long scale. We tried it with chromosome 21, that was our first try, because our plan was to run on the whole proteome, which we did as well. So this is an old slide. But this was to identify the problems with the workflow. What was very important for us that Taverna showed us, and the other tab in the results tab, that you can see for each processor how much time it took and how many times it failed, and all these statistics. We took these statistics, we looked at it in details, and we developed this second product workflow in production, and that's version 106. So this is the second one in production, just to show how many steps in between, because we work on each single processor here on its own. And then at one point we were very, we didn't know, I mean, there was no other way but contacting GPMDP, one of the databases for asking people, we need this interface. Please design this interface for us, otherwise we cannot really use it very efficiently, because we were wasting so much time in this data, retrieving the information from that database. They were very kind, developed it, and now it's actually one of the fastest blocks in this whole workflow. So this block is really the fastest in the whole workflow, which was very nice for us. Any questions about that part of the?
So you said you found kind of the slowest or the most difficult services in your workflow, and then you rebuilt those bits of the workflow to
exactly. So we rebuilt it in order to make we find it, and then we investigated. So one of them was exactly retrieving this information from one of the databases, and we don't have. We didn't have interface. We really were downloading the HTML, passing the HTML, and then the work interface was. I mean, we knew that the HTML was produced from querying their database, and then we told them, guys, would it be possible to have direct access to the database, and then send the queries there directly? And it was possible, but it costed them around 1 day to develop it, and then it was great. I mean, that we were able to access it. So this was actually the main. Just to mention that the main thing for this workflow was to make the list. Other advantages or other things that other people were interested in that because the workflow looking at all proteins in what's in Unicode, for instance, we took all the human Unicode proteins and then put it in the workflow and ran it. We were able to identify all syntax errors in Unicode, and we sent it to them. They correct in Unicode. So these are the things that you can identify, you can get from such, like it was unintentional. We didn't know that, they didn't know that the syntax errors. And that was really interesting for them. So other workflows that we developed also in the past, for instance, the cloud computing services, I saw it on Carol.
Yeah. I steal pictures.
One of your slides. So this is the original one. I don't know where the other one comes. So these are two processors. These are Java processors. The nice thing about this workflow is that it's running exactly locally because you cannot send the data outside the hospital. Doing something in the data, decomposing it, and then sending the data decomposed to different sites so they don't know from each other, and then retrieve the information so they cannot. So the idea was behind it, we distribute the information to different sites. They don't know each other, so they cannot connect to each other and build have the whole picture. And then we get the information together in the hospital, and then we compose it. What was very interesting about it for us is that it outperformed the MPI and the Hadoop implementation of the same thing. And that was actually because of the simplicity of it. What we did here is that from the beginning, we said, okay, cloud computing, we define cloud as any machine cloud computing machines, any machines out there which we have access to. That means it doesn't have our software, we access it, we log in, we install our software, we run what we want, we take our result, we delete everything. So that was the first requirement that we put. And then we implemented this way. That means the virtual machine that we were running was very lightweight. So run immediately, turn on immediately. Our installation was very straightforward. We deploy our software and we run it and we retrieve our information. We didn't spend a lot of time like MPI orchestrating and all this stuff. So it was all from the workflow, controlled from the workflow. And then you can see here actually this is one of the highest improvements that you can see. We managed to have improvements in different species. So like Ecolite has small database, Human has big database. So you need to deploy a lot of information on the virtual machine or in the cloud in order to run the search on the Human database. And what the workflow is doing is like we run a sample on the mass tape, we take the results, we send it to a search engine, and then we retrieve what proteins it's in that sample. So the search engine is set to match proteins with their theoretical mass spectrum. Does it make sense? Or?
How do you explain, what do you think is the reason that it was faster? Is it because it was not so parallelizable, or why?
So actually, one of the reasons is also the way of how we decompose the data.
Yeah.
So so I don't know how the MPI exactly, the API implementation or Hadoop implementation is doing that, but we didn't waste time in communication. We knew that this is the data, we have 8 nodes. Yeah. So this is again, looking at that other tab, where are you wasting your time? And then we figured out that 64 nodes is actually the optimum to run on such a big file. So
you kind of split the data according to your computational requirements.
Exactly.
Yeah. So that.
And then send it and to the information. Other workflow that we work on is like building spectral library or building spectral library. So that the idea was we have another, we want to identify proteins in embryonic data. So what we do on embryonic samples, or when you get samples from embryonic stages from not so advanced stages from zebrafish, you don't have a lot of proteins, you don't have a lot of differentiation there in the proteins. And the idea was, okay, we take an adult fish, we dissect it, we take each part in the fish on its own, we build specific library for each part, and then we compare the spectra that we get from the embryonic stages with this library, and then we identify the protein according to that. And then the hypothesis was we will get more hits or better hits, and that was the case. But to do that, we need to build a library. And to build a library means that we need to handle a lot of data from each organ. We've got a lot of samples, and then we run it on mass tape. So really huge amount of data, a lot of files. So this is, you see here, like it's almost 300 gigabytes, but that's because we put what we call centroid data. master 20, and that's reducing something like 2 gig to 200. And because we don't have the capacity to store all the data. And we ran it, and it worked very well. So this workflow was running for 5 days. We set everything, ran it on the server 5 days. After 5 days, the library was there. We were able to run the session. And then it was very nice, very easy, we thought. And then we said, okay, let's do more libraries. And then now it's running every now and then to build new libraries for something different.
That's very nice. That's kind of, big batch, build it, and then you do things on top of it.
Exactly.
Do you want to do this? This is the automated thing that we originally thought of the work we were doing, and then refreshing it. It's very nice.
So just refreshing it from now.
Yeah, this is a curation kind of database building.
Exactly.
Yeah.
Building database that and you need to do it from time to time each second month because the data which is available out there, it's being also changing. It's like it's a moving target. We call it always moving target because this is for instance like a few months ago they released a new sequence of the zebrafish, so we need to redo the whole work again.
Yeah.
Because then you can identify more proteins now.
This would be a very nice case study.
And that's a single run of the workflow, not multiple runs.
Single run, like 5 days. 5 days. Single run, take all the data, process it, and then so this workflow is here. This one. It's not research.
Yes, build the library and then rebuild the library later at another day when you need to rebuild it again.
But they're sort of lucky because I guess it just press a button.
Yes, batch.
Yeah.
It's a batch
Exactly.
thing. Yeah, that's the original
But
vision.
Taverna has a problem that he has to sort of work with it for 3 days. So after a while, they get on to the next stage of what wants to do with interaction.
Yeah, no, but this is library refreshing, right? And well then perhaps they shouldn't have a workflow that requires you to be tethered to an interaction. Just saying.
Over. Our workflow is quite typically uses a lot of interaction because at some point it'll be shown to a clinician or to
Oh yeah, you're different.
researcher, and they have to look at the image and say, oh right, that's cancer or not, or whatever.
That's a completely different
So you need the human as a service afterwards to run the workflow.
That's different. This is constructing a library that you need to reconstruct every now and again. This is a curation activity. This is a data building activity, database building activity, as opposed to doing an actual, specific tool. But that's why I like to you don't have any of these.
The thing is that once you build the library, you will be used as a discovery tool, so part of the discovery tool. But the library is, so it's a part of your discovery tool. You need it to be refreshed from time to time. So that's the idea.
How do you deal with errors? I guess you said you found bugs in Uniport data. I guess similarly there could be some problematic entries in the original data you put in here, or you have to do some kind of data cleanup, or you detect that, or do you get errors during the execution? Or?
Yeah. So in this one we didn't because it's our own data, so we know which are good and which are not so to filter, so to say. So the pre-filtering is really an easy step. I mean, we don't. So you see here this one. This is Compass Export. This is just like a tool name which will transfer the data from one format to the other, and in that step. So this is very, very interesting actually, I should say that. So this is running on Windows. And this is running on Linux. Because this is the vendor software, and it's only available on Windows. And then because it understands the data from the machine, it will immediately then correct it, so to say. So we get kind of clean data for the next step.
Well, I wondered if you would get, like the occasional error, like Taverna error goes red on the single entry or something like that. That execution falls over on one particular value or something like that.
From Taverna.
Yeah.
That Taverna tool did it for
Yeah. Or like,
We get it on the other workflow, we get a lot of these, well, not a lot, some of them, but mostly they are, so, so if you are aiming for fault tolerance. So
Yeah.
the workflows that we try to make it fault tolerant, so each of these boxes has some kind of fault tolerance inside of it, and then it will, so it won't fail, but it will report the error.
okay.
And then it will continue, and then once the error is very, how to say, the error is vital, or it is vital information that you cannot continue with it without it, it will break. It will report the error, okay, there is error, show it as red.
Yeah.
So we try to implement kind of fault tolerance, and I won't go through that once fault tolerance.
One feature we haven't got is that a single step in the workflow can't say just give up the whole workflow, because it could often happen that if something's fundamentally broken and there's no point in processing the rest of the workflow, but there's no way for it in a single service to say that, it will just fail.
Exactly, it will fail the whole,
Yeah.
it will stop it. But that's, yeah, it happens, and that's one part of the, why you build the other workflow,
Yeah.
what I showed before, the version 106, that you saw it in the box, because we are controlling from outside, whenever it fails, okay, it fails, report it, continue.
Okay.
Other thing what we like to do is 3D visualization. In Taverna we were not able to do that in Taverna, so we said, okay, what do we do now? We let Taverna reduce all the data, and Taverna start the software where we are showing the 3D visualization. And in this case, we thought, okay, let's do it as simple as possible. We make everything as HTML file, and then we start the browser, and then we show it in the browser, and then we can turn it around because it from the other side. And then at one point we had here also kind of Luke questioning the user which perspective you want to see, this one, that one, and then it was showing this at one point, showing like 6 Firefox open at the same time, and then showing 6 different perspectives was a bit too much for the user. And this is kind of data integration. You need some things whenever we integrate data and see from, like, yeah, we want different perspectives to see the data, especially in, yeah, the same.
And you broke it as a special extension, as a special plugin to do that?
No, not at all. It's just like we are generating the data in Taverna, and then with that Taverna start the browser. So like when I start the browser with this HTML file.
The data is generated at the end. The HTML is actually generated at one point in the web.
Exactly. Yeah, exactly. So and then the data visualization is just like holding them. So this one is part of one of the outputs. So it's Venn diagrams 2D. It's possible to show it in Taverna. We show it in Taverna, but the other 3Ds are all outside Taverna. So like it's just like simple output hacks around Taverna in order to make what we want to do.
And I think we generally all moved in that direction, that we want to outsource rendering of the outputs.
Exactly.
It's too much to cram it all into.
Taverna. So Taverna, I want to call Taverna as a visualization tool.
Yeah.
It can do the 2D, can show some figures, can fix some figures, but it's not meant for advanced. It shouldn't be as well. It's not a tool for advanced.
They're specialist tools for that, and anyway, they're very domain specific.
Exactly.
Tools. So we have the same with the biodiversity. So they have specific maps with specific layers, and the BPH people have glorious tools for visualizing their avatars and doing all of that.
Beating heart.
They're beating hearts, absolutely. So there's no way you can get, make their entire careers on how to visualize that stuff.
Yeah, exactly.
So we wouldn't be so
Play
arrogant.
Sims with the avatar.
Exactly. So, and then we try to build a plugin for Taverna. I won't say it is so far complete, but it's at least the first step. what you can see, what we did is that, yeah, I mean, like normal plugin with our services. The thing about performance is that you are dealing with big data, specific software. So I'm not sure if it is really very useful to put it all as open source in the main web service or as web service in like outside, because you will need to upload a lot of data and download a lot of data all the time. So and then we went into this problem, and then we said, how do we solve it? Okay, we designed then our upload and download service, which will deal with big data. And you said, okay, let's try it on really big data, the biggest data that we get. We got like something like 6 and 7 gigabytes. It works fine. We upload 6 gigabytes to the server, run everything, download 10 gigabytes. Because the results is always bigger. It takes time, but that was actually one of the main intentions for us. How do we deal with this big data that we are producing in those jobs? So far, that was it. Some acknowledgement. These are my colleagues in Leiden, Victoria, and the Hof School, our work with technology, this work, and thanks for your attention. If you have any questions, I will be happy to answer.
Very good, very interesting. There's a whole bunch of things there that I can see making showcases for sort of our website, because they have different aspects to them, you know, build different use cases. So it's very good.
Okay, now, yeah.
What's your experience of developing work? I'm sorry, a plugin? Because we have a few people.
So I would say this way is not to offend anyone, but it's a really complex system. So you take that was 6 months working just like to have the students be able to understand what they are going to use. And one of the valuable things that we did afterwards, I didn't show it now, it was actually on my browser, that I thought that one of the most valuable things that this student did is that he understood what he did, and then I asked him, I want documentation.
Yeah.
Detailed documentation for user and developer, and I want videos. How to install each step in Eclipse from zero. So you install your Linux, and then till the point that I have the plugin that I can press on the button and download. So documented videos, and that's actually was the most valuable part of this.
That would be something to share.
We would be happy to share.
Yeah.
That's interesting that you said that we do this all the time. We get master's students or undergraduates to run through some piece of software just so that we can learn how it operates.
No, yeah, you know,
I mean, it's a valid project in itself. I'm not disagreeing with that. But it's just that we don't have time to actually fiddle around with all the knobs and buttons. They fiddle around and then tell us, here's how you do it. All right. So master project is not they learn, but we learn as well. So I think
no, it was not intended for that actually. That would be much like straightforward. But then he explained how much it was, how difficult it was. We said, okay, let's go to the application.
We had the master project with the developer getting a mobile app for talking to Taverna server, and by doing that, we realized that Java library we had didn't work on Android just because of how it did HTTP calls. You didn't have time to try out that to think, well, why would we need to spend time with the students? And you could send them into this explorative kind of thing. Is it in there? Yeah? Yeah, it should work. It should be the computer the dump for the solution to 1990 laptop.
Is the MacBook? Or is it PDF?
It is, PowerPoint on Mac.
Wow! Woo!
It's normal, first-year students can do things their supervisors can't anymore.
So I was informed that this is a lightning talk, so I have a few slides and I might be a bit fast. I'm working on workflow problems and I'm like a third year PhD student. So
I think it's you.
the title for work that I'm doing, that I come up with is this. So if you can
Okay, so if you're next, you're fine with that then? Yes. Yeah.
So it's understanding the utility and fitness of workflow problems for experiment reporting and Carol's master supervisor. So in the morning, Carol mentioned that there's a life cycle view to all things that's done workflow-based science. And particularly the focus so far has been on the research part of the life cycle. So previously, like in 2001, people were doing this analysis in an ad hoc manner, okay? And now that we have all these established workflow systems, we can do it much better. But the thing is, it has proliferated the analysis and the rate that it can be done. So we have lots of results now. So the bottleneck has kind of moved to this part now. And so the new emerging, let's say, area of effort is going to be on the area of reporting, because scientists have lots of results and they only report some of it, so they collect some of it, and they document it, they annotate it, they type their resources, or they try to group their results by origin, or they try to document important ground parameters and that sort of stuff. And I mean, this is a quite recent survey of scientists that they acknowledge that there are lots of workflow systems, lots of pipelines and portals that allow us to do the analysis, but there's very little tooling to allow us to manage the results. Okay, so on the research side and on the workflow side, okay, on the left-hand side of, let's say, the previous figure, we have provenance, okay, and that's automatically collected for the workflows. And this is also, for instance, for Taverna, it's already nicely built into the tooling, so you can get, if you have ever used that export result, pay result screen, you can pay results as a flow export, nicely developed by Stian, I think. What you will get is for each invocation of your activity, you get some generic information about when it ran and what it consumed, what it produced, and that kind of relationship. An important thing to note is that it gives no information as to what happens in terms of any domain-specific mean, or it doesn't tell you what the data is in any way. It's just a very, very generic trait of the execution. But then on the other side of the, let's say, there's this life cycle of research and there's the reporting life cycle. When scientists document the results or they write a manuscript or so on and so forth, when they say provenance, so there's the overloading of the term. Well, what they mean by provenance is actually the scientific context. So what was the query that they used? What was the trigger? What was the calibration parameter? Or that kind of scientific provenance of the data, right? Obviously not the generic information collected. So there's a big bridge to, if it's at all possible. So there's this workflow side and there's the manual provenance information that the scientist needs to provide, okay? So we are investigating if at all possible, if there are little focus spots in the workflow that we can collect some of this scientific domain specific information, okay? So to do this, so you need some intelligence. So you need to bring some intelligence we took 240 workflows from different systems, not just Taverna, and different domains. And we simply, like we were very uninformed people, like we don't develop workflows all the time, but we understand what roughly they do. We try to characterize the activities of what's being done there, okay, without actually looking into the science, but very roughly. So in our characterization, we have classes like data retrieval, data analysis, data visualization, data moving, or data splitting. That kind of very basic characterization. And what it shows is that there are composed protein workflows, right? And then there are the adapters, the shims that Carol mentioned. And they often, for almost all domains, they make up the majority unless you are using specialist components or plugins. Okay, so we have this characterization and we claim, okay, that often scientists don't just build these activities just for one workflow, but they reuse it. So the idea is, if you have this classification, then that can be propagated into every workflow that this activity is being used in. So we call these classification workflow motifs. Okay, so now in my research, what I do is, let's just assume, okay, we have this little bit piece of intelligence, okay, that tells us the hotspots in the workflow, and that tells us how data is relayed, that's how data flows through those adapter steps, okay? So I have this little piece of, even though it's little, it's a big assumption. If I have this additional information, what can I do with it, okay? What does it bring me? So previously, living in the black box world of problems, scientists have tried to abstract workflows using just separating steps as important and unimportant steps. And I try to see if this gray box abstraction can make an abstraction more effective in certain dimensions, particularly, for instance, effective in revealing only the code that the scientist is interested in reporting, not all the intermediate codes, for instance. So that's one research that I've done. And the other piece is, if I go back to the workflow, so workflow, this one has only one input parameter, right? But often they have many parameters. And what we feel is that those parameters are often important, like for instance for the video case, the parameters are the query string, or for life sciences, it's the species. So it's that's very valuable, but very few labels that you would want to go with your file, without or without data, that you could collect from the very source of the data, actually. That's where the retrieval of the data happens. So the idea is to collect these information, and we do that by using the workflow provenance as like a broad map. So for the hotspots, and we collect labels for data, and for through the adapter steps, we relay this data in a very simple manner, and we try to see if it is effective or not. And we try to see if it's effective by just comparing it to vanilla provenance queries, and if it's any effective or not. So that's my research. How do I use Taverna? So this is my workspace, and lots of projects only on the average probably have 2 or 3 classes in that. I very much use the workflow structure and also the provenance for query. So I use Workbench a lot. I use the couple API. I've used the couple API to first of all inquire about the details of workflows, and also I use a contribution from the Workflow Prior project to convert workflows into an abstract representation, which is the WSS, okay? But then that abstraction, well, in terms of issues, what I came across with is that abstraction is a way, it's just there for, to be able to talk about the workflow, okay? To be able to refer to the workflow, refer to its activities. but then I need more. What I need is I need the activity test, for instance, or I need iteration handling behavior, and that's not kind of exported into this.
Because you want a concrete description, not
Yeah,
the
exactly. I
abstract.
mean, the concrete, yeah, in a way. So, I mean, I think that's because the WFS isn't really initially designed to do that kind of. It's not designed to represent all the characteristics of the workflow. It's just there to, as I said, talk about it, to be able to point to it in an RDF document, I think. So that was a bit of an issue. Another thing is that while I was using the workbench, one thing I struggled with was that annotating activity was a challenge in terms of just if there were just key value kind of annotation that I could use, that I could answer about workflow, that would be useful. But at the time, the workbench didn't have that, so basically I had to invent my own pretext formats and then parse it to get my structured annotation. Another thing I think is I would like to mention is resource uniqueness. So Taverna, when you open up Taverna, it has this world view, right? And if you, let's say, copy two instances of the same web service processor into the workbench, all right? I mean, it is technically possible to detect that they are the same thing, but in the workflow description, there is no awareness of that those two processes are realized by the same resource, okay? So there's no notion of this is a unique resource, right? So I'm wondering if that worldview is going to change in Taverna 3. So I think that's important because when you export to the Taverna workflow to the workflow that we have there, this is important because you lose it, you have two URIs for the same thing, and I think that's a big thing for like linked data scenarios. I think that's important. So anyway, so that's what I've done. I have used this Couplelize API initiative to build a workflow. I do labeling by pipelines as well. But then, I mean, obviously, Taverna team have their own deadlines and stuff. So rather than being just dependent on it, just waiting for the C3 schedule, what I did, I just generated a closure pipeline basically because I mean my expectations of the pipeline is really limited, so I just do labeling with a simple closure pipeline. But yes, as I said, I have been one of the initial initial users of the couple API for automatically creating a workflow. So that's it. There's something I have missed, basically, and that's animation. I don't know how that happens. Okay, so this is I did something I realized while I was doing some experiments on testing the precision of query results. Okay, with label workflows and unlabeled workflows. Is that in the formula specification right now? There is no order of the ports, okay? And so you say it's a cross product of two ports, right? And I think in XML, when it's serialized in XML, it's serialized like there are two port elements here, and there's no notion as to which is going to come after the other, right? It depends. I think the XML spec doesn't really say anything, doesn't really prescribe anything in that. So
no, I think the first one is the outermost one.
Is it?
Yeah, the order does matter.
Does it matter?
Oh yes.
Okay.
Especially if you have three. If you have just two, then you're going to get same kind of list anyway. But if you combine three ports, it really determines which is the outer or the inner list. So the order does matter.
Okay. So okay. So
Yes,
it's
well,
just
sorry, the order ultimately doesn't matter even when you have two, because it will whether you have a 3 by 5 or 5 by 3.
Yeah, it's true.
There's nice examples in the starter package. There's something about configurable iteration.
No, what I mean, it might not matter in terms of running it or anything. What I mean
for running
by that
it,
is,
yeah.
let's say you took this order, let's say you took schematic and extract, right? Schematic number 1, extract number 2, and you ran it, okay? And when let's say somebody else using some other XML parsers are querying problems,
Yeah.
okay, and if they assume,
Yeah.
if the parser tells them this is the first element here, then they would get wrong results.
Yeah.
Okay? So that's just some finding about the representation.
We should be looking at the link between the resulting output list and the iteration strategies in a way. It's like it's an invisible service in a way that wraps out in a way.
In Dataworks, as I saw yesterday, I explicitly represent orders, but I mean, I'm sure all XML parsers behave similarly, but you know, it's just a note.
I think if you look at the RDF version of the strategy in the Scotland 2,
Okay.
inside the bundle, I think it just have an index number.
All right.
Yeah.
Okay. Okay.
Or it's an RDF list. It's one of those. I don't remember. Oh, thank you.
Any questions?
You have. You emailed it, right?
Read item number 2, but read item number 5. The output will be 1, 2.
I did have to go with this name, I had to make it.
Just reading the. Yes. 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 No, it should be the same because because they it can start the process of getting the it says waiting. It depends on the data. Maybe smaller.
Yeah.
It's really neat, isn't it?
Okay, so I am Gabor. I am leading the Airflow FP7 Airflow project, and I consider the request not to be too long presentation. I hope it will not be too long. I included two keywords. The first one is missing workflow usage. I still remember Carol's favorite phrase about the workflow sharing, even if I cannot reproduce, but it was not very positive about the workflow sharing. It is my memory. Okay, so basically we developed two workflow interoperability solutions. The first one is based on the black box approach. We call it the coarse-grained workflow interoperability. To manage the workflows, we developed a format description. We describe the workflows, particularly describe the abstract workflow, the concrete workflow. We also specify the workflow configuration, and we identify the workflow engine which can execute a particular concrete workflow. In order to support execution of different workflows of different workflow systems, we also describe the workflow engines. The idea is more or less the same, but there is no pointer of the workflow. How does it work? Let's consider two workflow systems. The workflow engine is a so-called host or native workflow system, and we want to execute, for example, it is a prepaid workflow system, and we want to execute a Taverna workflow as a black box. The first, we have to produce a description of the workflow, and we have to upload it to the repository. Then we develop the submission service. Previously it was Java, currently we have a new version. And we have to integrate the command line client of the submission service to the workflow engine. Okay, so let's move to a real example. I have a workflow which contains 4 nodes. Job 1, job 2, job 3 belong to the native workflow. These are either jobs, there is a job which is a simple job and 2 prepaid workflows. And the fourth one is a Taverna workflow. The host workflow engine, when reaches the job 1, workflow 2, and workflow 3, it manages in the default way because they are prepaid workflows. When it reaches the workflow 4, the control is taken over by the submission service. It retrieves the workflow description and it submits to the workflow engine. And from this point, the submission is controlled or supervised by the workflow engine B, which is in this example a Taverna workflow. What is the advantage of this approach? If there is a workflow, to describe a workflow using the format description which I presented takes a short time. We are talking about hours. It's a little bit more, it requires more effort to create the CGI support for the workflow engine, but there are only a few workflow systems and there are a few hundreds or a few 10 or 10,000 workflows. So if there is interest from a community to use this approach, then it is possible, but it takes effort, which basically it's between, it's about few weeks. It's a reasonable time. I will present the 2 scenarios. Probably the second one will be more interesting for you. In this case, we are not talking about workflow interoperability. This is the platform which we created, which we call a Shiva simulation platform. It contains a gateway, which we call Shiva portal, the Shiva repository, which is a workflow repository, and then I will explain the other components later. So, if you use a host workflow system, you have created a workflow, you tested the workflow, you are happy with your workflow, then there is a service which retrieves from the workflow description all the data which you need for the format description. The gateway generates a bundle, which is a zip file, and the zip file is automatically uploaded or exported to the Shiva repository. So it means that this is the automatic upload operation. It is possible to do upload, export operation, or upload operation manually, but you have to learn the repository details. Once the workflow has been developed through the gateway, it is possible to select the workflow, import automatically in the same way using the same bundle file, and then it is possible to submit. As an extra service, it is possible to deploy a gateway and to connect to the repository and import a workflow and execute it. Let's move to the second scenario. And in this case, I will explain how it is possible to execute Taverna workflow. The assumption is that the Taverna workflow is in the My Experiment repository. You have to go to the My Experiment repository, browse it, to find the workflow which you want to use, remember the ID, then you have to go to the Shiva repository, type in the ID, and we retrieve the workflow description, and we upload the workflow description into the repository. And at the same time, we enable its execution. All this process is done automatically. So it means that if there is a Taverna workflow, you can upload to the repository, and from this point, when you want to execute to the Shiva portal, the portal reaches the submission service because it is not the native workflow, and the execution is forwarded to the Taverna workflow engine. What is a special feature of the Shiva repository? That if the workflow is there, you can execution enable, and you can execute this workflow from the Shiva simulation platform. We created a solution for these workflow systems. We support the Galaxy, but the problem is that all the other workflow systems have a well-defined command line interface. The Galaxy has an API. They always develop their API, and then we have to upgrade the extension. They have promised a few times to create a command line interface. Maybe it is already there, but I am not aware. So this is the way how you can execute the workflows. A few details. During the last few years, we worked with the following academic and non-academic communities. Because we use the Figure Gateway, the native workflow system is the Figure workflow system, but you can see that I listed those workflow systems which they use. The number 2 is a Taverna. And the key communities in this aspect is the astrophysics and the heliophysics. And I didn't know that you are behind the helio plugins. We use in the Airflow project. The helio community used the helio plugin. And it really helped because when they didn't use the helio plugin, they had many problems. The web services disappeared, then they were not able to execute the workflow. It's a good solution. I like it. So basically, these are the workflow system which I really use in this way. Here is some statistics. It is about the Airflow project. In the first year, the workflow developers and the user created 242 workflows. Basically, the real number is 119, the concrete workflows which can be executed. It's a strange number because somebody created a workflow, abstract workflow, but there is nothing behind it. So I don't know why, but it's not my business. I collected the statistics. What you see in the second year, there is a significant increase because the communities learn how to use the technology. Only one of them had any idea about this platform. These are the execution numbers. We distinguish between development, test workload, and production workload. Okay, so one point, and I would like to jump back because we had an idea, but as you know, what you want to do may change. At the beginning, we had only this platform. But during the project, more and more community deployed their own gateway, and we defined a new strategy. We use this platform basically for development. For example, if a community would like to use a new desktop grid resource, new service grid resource, cluster or supercomputer, or there is something new. Once we create the connect, the gate, the platform to the new resources, we develop CGI support for the new workflow system, and from that point, they, when it is completed, they implement the solution on the community gateway and they use it in production. I was asked to give a short presentation about the other approach. There is no Taverna support because the fine-grained interoperability is the other option. It is based on workflow language translation, and the major advantage that it's flexible if you compare to the black box approach. You can change a workflow. For example, you can take a pre-created workflow, convert it into an intermediate representation. Then from the intermediate representation, you can translate to a Taverna workflow. But there are two constraints. First, you have to develop two plugins, convert from one workflow into the intermediate representation, and then to develop another plugin to do a second translation. And it takes much longer than to create a solution for one particular workflow system. The second problem, there is no perfect translation. And the workflow developers do anything what is possible to prevent the translation. Okay, so I finished the presentation here, and I raise a few questions. Who uses the workflows? Based on these two projects, our conclusion, the workflow is a toy for a few hundred or a few thousand workflow developers. Maybe it is my personal point. We cannot reach the domain scientists in the numbers that it is expected. Because one of the reasons we develop excellent workflows, we ask the domain scientists to use them. If they really use it, 1 week later, they ask you to change it. It happens first. Then they will come back in 2 weeks' time to change again. It happens second time. But after third time, they don't come back because they cannot work this way. You have your own project, you cannot modify the workflow. This is one point. The current policy or the current approach is not flexible enough. The second point, the workflow developers, it is my personal opinion, make a major mistake. What is your favorite workflow? Which contains one node, maybe 2 nodes, or which contains 50 or 100 nodes? Do you consider yourself a real workflow developer if you are able to consider a workflow which contains only 2 nodes? Do you? Yes. You are the only exception.
Because he's a workflow developer.
So basically, I met quite a few people, and they are very proud if you are able to create a workflow which is, if they display them, I don't say anything than only minor points.
Not if they work for me, they don't.
Most, like,
Smaller the better.
yeah, like most.
Yes, but in this aspect, maybe you are different.
1 or 2. Modularity. This morning we talked
Yes.
about components, about making small modular fragments, how you combine those fragments. That's all the work that we've been doing for the last 2 years.
Yes,
Because that's the right thing to do.
Okay.
Yeah. I think you're right too.
Yeah, okay, but it is not
I think the
basic
problem
approach
is-
in the workflow developer community.
Yeah.
That's probably true. That's
Yeah.
probably true. We're probably exceptional.
Yeah, but I think it's because most workflow designers are not programmers. Well, as a programmer, you would start to pause the moment you have like 100 lines off which shows, shouldn't I make some functions over here, right? Refactor your code. That doesn't always happen with workflows that you shrink and compact and reuse. when you have a seasoned workflow designer, that's what you do. And then you get these nice, simple workflows that maybe if you drill down to it, there are more complex bits to it. But overall, like your Siemens workflow, which would have 3 steps or something, and it processed hundreds of gigabytes of data.
Okay.
Is there a spectrum?
Yeah, you know,
At one end of the spectrum.
different. I mean, if I approach the whole thing from different point of view, I mean, Google approach, map and reduce. What we are doing is actually a lot of mapping and then reducing. We are retrieving data and then we are reducing it, but in a different component. And for each database or for each mapping that we are doing is like you need one.
Okay, do you consider yourself a computer scientist or domain scientist? How many of you are domain scientists? Here. Do you develop workflows on a regular basis?
Yes.
You are exception. Congratulations. Because in most cases, when we have a further discussion with the domain scientist, when they reach a point that we tell them that you have to use workflow, then you don't see them anymore.
Well, quite right, because they shouldn't have to.
Yes, yes. Because then we are trying to explain them. They live in a world where they have marketplaces, where they have app stores or anything like that, and they expect a similar solution. So if you try to flood them with too many technical details, they will not learn, and they are not expected to learn. Because I had a different interesting question. When I try to convince, or we try to convince them, the question, are you going to learn the bioscience? No way. Then why push them?
I think your question is completely flawed. I think you're really barking up the wrong tree, because the thing that you're complaining about are to do with workflow design, which there is. So when we develop workflows for biodiversity people, which frankly they really don't care about what workflows look like, but they do compare about adapting them. But we build the workflow so that they're adapted. So you change the data set, you change the parameters. This is what we mean by change. Usually is I want to change the data set, I want to change the parameters, I want to change the layers. Part of the workflow design. We don't make them do the workflow. That would be silly, because there's some thought that has to go into how you put the workflows together. So you're kind of arguing that by making it a bad thing to make domain scientists become sophisticated programmers. Well, yeah, you're right. That is a dumb thing to do. But that is
That's exactly what we have. Why we have astroinformatics, why we have bioinformatics, why we have.
But you see, it's I like these things, but I'm not absolutely sure it's a good option.
Well, I remember actually
it's not difficult.
A really profound moment when I was talking to your chappie in Sheffield.
Marco.
No. It was a guy in the hospital. He was incredibly impressive. He came to see us in Manchester, and he works in the hospital. Stephen Wood. Now, Stephen Wood, he wrote Master Splendid. Where Stephen Wood works in the hospital, and he said all these years, and I paraphrase him, but you were there, all these years he'd been banging away about getting software, preparing software for clinicians to use. And he realized it didn't matter if you even just said, press this button, it wouldn't make any difference, because that's not the point. The point is that there is a whole world of technicians that support him, and he would never think of laying his hand upon doing radiography, because there are technicians who do that. What he wants is a final report, and what we are doing is providing the equivalent of the radiography department, or the oncology department, or all of those technical departments that do all the testing, that you then say, go out and get me this result, and what I wanted is a nice report, So it doesn't, we're just like the radiography department.
Well, to take your point a little bit further, in the Sheffield Imaging Hospitals, we have something now called 3D Lab, which essentially is the image processing stations for all the radiology data that comes along. Essentially what they do is, all the data comes along, they run a workflow, not they have their own radiology. They run a workflow which somebody else has totally tried to get there, and then they generate a report, and then they send it off again.
Yeah.
But what? Each component in that workflow requires somebody to codify, some scientist, some domain expert, or to say this is what this component does. And the three lab technician would say, oh, I've got these components, I'm going to put them together to generate a report. There's levels of abstraction that are going up and down. So I think the science is still important. They're doing actual science, doing the technician, the workflow designer would be the workflow designer, the workflow infrastructure people are also important. And all of them are on a spectrum. And saying one is not good for the other. But that's right.
I agree entirely. That's why there's the entire discipline of bioinformatics. Because there's never going to be medical informatics.
Bridging this question, we cannot expect from scientists from medical doctors to know what.
No.
But you need someone to understand what this medical doctor is saying. In order to translate it into work.
In a sense, just precisely describe my job.
My job is essentially go and sitting with scientists and say, what do you do? What is your problem? And then translate that into a workflow and build an infrastructure to support that. That's essentially what
I think the advantage for workflow is that you can still point to it and say, if you do A and then B and then C and D, you can kind of somewhat have some kind of conversation that is somewhere between abstract and concrete, because you can run it and he can see the picture.
Well, we have these people in labs, they're called technicians. So I've never seen a professor go into a lab with a white coat and say, okay,
Carol, when was the last time you started Eclipse, Carol?
Yeah, exactly. It doesn't happen, right? You have technicians that run the experiments and stay up all night. And that's what PhD students are for. And they do all the technical stuff, and then they go down and say, oh, that was easy. What, I've been up for 48 hours straight, making sure that the instrument was still there, blah, blah, blah.
No, Rod does this all the time. Oh, this is just a half an hour job, when it actually is a half a month job.
Exactly.
Half a year job. Half an hour. I did that ages ago, about 4 years ago.
Okay, but my point is that the workflow technology is excellent. What we fail, and we are still failing in one aspect, that we are not able to sell this technology as it is expected, or as we would like to do for domain scientists. Because it's great to hear that you came to the same conclusion as we have made. For example, we work with the computational chemistry. They use the Chromax, and they started to build up a library. There are not too many workflows, but these work because the Chromax is huge. And if you are workflow developers, it doesn't mean anything from you. There should be at least two persons, or one person who is familiar with the workflow technology and with the Chromax. And they created a team, and they are building really small workflows, maybe so one node, two nodes. It's not about the node numbers, it's about the functionality. And having these building blocks, maybe it's not the perfect solution, but even the domain scientist can use a dashboard or something like that to create our solution. Because the next breakthrough will come when they will be able to use it, and they will not. They will depend on the workflow developers, because even if you have these building of workflows, they can fail at any time, and they will not be able to fix identify the problem. But what is the major challenge? To provide a more flexible solution, and to consider what they want, to consider not only what we want. Okay?
Sorry.
I just comment. We have to separate our expectations to the three
you want, because everybody wanted, even in usual programming, you want jump boxes. So I remember 20 years ago, people was doing this weekend programs are dropping the boxes, doing some errors between them, which is relevant, and they have problems. Obviously, it's a dream that everybody wants to achieve, but the reality is, if we are really healthy, I mean, web services now create what you really want. Often, if you get 5 persons of the fail web services, you can workflow with 20 of them, you can almost 100 persons that workflow with fail. But I think, for example, about the products, in also we need molecular dynamics, package, based on viable services. There was a lot of viable services. The key workflows based on viable programming. It was hard to define a lot of parameters. Yeah, it's possible. It's not perfect, obviously, it's not perfect. I'm not sure. Probably 10 years we could discuss the technique about workflows and scrolling this new technology, or 3, 4, but
Yeah, I agree with you that this we're moving, and that now gave us Dunn's bombshell. You can't leave now.
Oh, that's
Come
speculative,
interested.
yeah.
Come on.
We'll take them to the station.
Okay, well, we'll contact you, yeah, I'm gonna set Irwin on you, he'll be interested in you. Okay. Yeah, this is the wrong person doing that, Centre of Excellence in Workplace. In biomedical research, that's the story.
But a workflow is not big. I mean, again, coming back from principle, or maybe a different point of view, altogether, business processing workflow is nothing to do with code, nothing to do with drag and drop. It's primarily sending emails back and forth, or a way of sending data back and forth. And in a sense, different applications provide different ways of putting together their work.
Just for the workflows in real situation, for example, I was asking to get information from website, there is no web service, no, already was I don't know, it wasn't something about content, relation, they get one website. And you get to hack, because I get to open the page and see that everything is done in Ajax, JavaScript, and Kali. So I had to find some Ajax, some point which parameter fast, and make Java programs that make post with all these parameters and get data back. And now, half a year later, it's a few months ago, it stopped working because somebody in the page changed parameters and pipelines and stopped working. And now nobody understands how it works.
No, exactly. This is why I expect that, this is why most workflows decay in the end if you're using something third party, because they change it. The best you can do is look at it and say, well, what did they do? And I might be able to make a new one. But yeah, this is an issue. This is quite interesting. This point is quite interesting because, if you try to make people program, they don't, they're not programmers. You can't ask them to do it. The point about complexity and showing off is quite interesting because this is, my workflow is more complicated than your workflow. I have actually seen that in practice. I'm glad to say, not on my team. Our idea is, oh my God, that's far too complicated, make it simpler. But I've seen examples, particularly in the commercial sector, where people have put up 9 workflows or pipeline pilot workflows and said, hey, look at this monster workflow I've done. I'm just going, well, it just looks like a big monster monolith. Why would you write a workflow like that? But they're very proud of it. So there is something to be said there about it's also to do with how clever I am, and therefore don't sack me. There is some issue to do with this. In fact, Bob's not here, but
they're afraid that if they say, look, I reduced it to 3 steps, and say, hey, why didn't you do that first time?
It
took 2 years to figure out what those 2 steps were.
Exactly. That's
Our badge on the size of the work, ours is more about we've got lots of data. We're computing on terabytes of data, and we're doing these many CPU hours of computation.
It's a different kind of, my plots are bigger than your plot. Kind of argument. But then you get a lot of this kind of big bragging stuff. Whereas when my students come and do their projects with me, my undergrads, I always tell them that it's the least amount of code that I want. So if they say they wrote 3 lines of code, but it does an amazing thing, that's better than saying I wrote 30,000 lines of code to do something really tedious. Don't care. Because these days, the 3 lines that you knew you had to do, that's the art of it, right?
I mean, there's a very famous story about Donald Knuth and Brian Kerrigan. And Donald Knuth was given the challenge of creating an inverted index from Shakespeare's play. And he wrote a very beautiful program in C and tried to do the inverted index. And Brian Kerrigan just used normal Unix code, 1 line, to do exactly the same thing. And it was just a single line of code. It's very hard to read code, but still, it's code. But that's the beauty of that. Bring back to the flexibility idea of analysis, where Unix tools are simple. And you can compose together into.
I disagree in one point. That, I mean, the code should be readable.
Oh yeah, absolutely. I agree.
You don't code for yourself.
You see the obfuscated C competition. It's genius. Yes, but no, I agree. Readability. And I would rather have something readable and longer than unreadable and short.
But I think the point I was trying to make was this composability nature, where you have these simple tools that do simple things, and you just compose them together into a beautiful. But the other program is not. I'm not saying that's bad. I'm just saying that's just solving one problem, and that's the only problem.
Exactly. This is why we try to bring in this that we've got this. We're dealing with this mess of resources. And if you can make them neat, then it's easy to compose them. And if you can't make them neat, then pretend that they're neat by making them into components. And in 9, they're called nodes. And in Pipeline Pilot, they're called blocks, is it, or nodes? I can't remember which one it is, but something like that. Every workflow system more or less makes this idea of making blocks of something so you can work at the level. So block, then you hide, you bury. It's a fundamental piece of programming. Is encapsulation. It's the thing that we're taught as software engineers with our mother's milk, how to do encapsulation.
You're saying there is no problem computer scientists couldn't solve adding another level of abstraction.
Exactly. I tell my students that. Put another layer in. Yay! And it will just go slightly slower. So absolutely. And sometimes that's and then if they're going to work in the games industry, they take all the levels out because you have to make it really go fast and you have to hit the metal.
I don't think there's much XML there.
No, there's no XML in Duty or True Duty or whatever. Call of Duty, that's the one. So absolutely, it's the last bastion of serious coding is games. But yeah, absolutely. But it's but this is why I put up the spectrum of tools at the beginning of my talk, which was, there's no one tool set. You have to let in at each point. And I've yet to meet a programmer who really wanted, in the end, to have just blocks. Because they really, a programmer usually wants to have something they can really lay their hands on. And so if you just say you can only do block programming, run away!
The problem in university software, I think, in all software, that nobody programmer is thinking about it yet.
Yeah.
I mean, you take any software, it will be plus.
Yeah.
It's just software that input, output parameters, and some operating design. Imagine that everybody programs software like 3D, like APIs. We can make our software.
It depends on your definition of programming. Because we have people who think they're programmers doing Excel spreadsheets and Excel macros, which is all fine, and press a button and whizzing things happen with Excel and massive calculations happen. So for them, they think it's programming, and it is in a certain respect. But for them, it's just they don't think they have the data. They do that, and that's it. That's all they think about. So it depends on your definition of program.
But again, one point that I want to make is, I don't know. I mean, I will take proteomics as an example. I mean, you get a lot of things that other group is working on this thing. Right. So programming is not the goal. The goal is to do something that's functional and publish it before the other group.
Yeah, that's right.
And all this streaming, all this, I don't know, I think you all have tried with new Java. It takes time.
Yeah.
It takes time to
We
develop
publish
software.
it. Make sure the software often is not optimized or everything. We publish and everything. Look, this energy is better, or this is better, and this is the point. There are not software issues, of course.
I would draw that, I see, you're completely right, the analogy is the lab protocol again. So you have a lab protocol, and it's the most elaborate, confusing lab protocol you've ever seen. The technician follows it, or you're making it up as you go along because you need to get the paper out. Then a technician, lab technician, looks at it and goes, "This is crazy. This step is completely pointless. This step is completely pointless. We'll skip it, we'll eliminate it, we simplify it, and that is the real protocol. And you're only going to do that if you're going to do it more than once. Or, so if you're just hacking it, you'll just follow the old crap until, to get the paper out. But then somebody else comes in, steps in and says, and it's, in my experience, it's never the scientist who comes in, it's the lab technician that does it.
Software developers always optimize and refactoring the code. They refactor the code.
No, I'm going home. I'm going back to Sheffield now.
Oh,
Sorry.
Okay,
Yeah, I'll see you tomorrow.
Send us your slides.
I will.
The slides are awesome. I want to play them in their animated version.
Okay.
Their non-animated version.
Thank you.
See you tomorrow. Yeah.
Just I think studying algorithms and everything is optimization.
Yeah, because that's our job, right? To do the optimization, and there's a degree of, there's a biologist, a bioinformatician, then there's, the kind of computing savvy bioinformatician, if you will, and then there's computer engineer, and each one has a role. Because the software engineer will try to simplify everything, make it generic, make it robust, make it run over things, put all the abstraction in. And somebody who's a sort of close biology bioinformatician isn't going to do abstraction, isn't going to do genericity, because that isn't their job. Their job is to get the paper out. And the biologist is supposed to say, what does my gene do? That's it. So it's kind of the tendency of computer science always to want to do abstraction generality, that's our job. And most scientists are interested in specifics. And you can see this explicitly in R scripts. So if you look at, because the other key antithesis of block programming is R, really, particularly the way it's really used in reality. If you look at our biodiversity project, has a lot of people using R in it. And you examine those R scripts, and they're basically one R script hacked to the next R script hacked to the next R script. There's no, their idea of parameterization is to edit the R script. And they don't use functions, they don't use anything like that. And it's because they don't really know what it is. And the algorithm is the R. And the R is the algorithm. There's no separation. There's no separation, no abstraction. They can't write down the algorithm. They can say, oh, algorithm, it's here, it's smart. No, that's the R, right? What's the algorithm? Oh, no, can't do that. So this is...
And with certain of them, if you want to change the parameters, change the R.
Exactly. So, I'm not lying, right? Alan's been there, done that, and...
Yes, yes. And some of it you actually have to get it to work, you have to sort of comment out specific bits of the R, and then the next time they comment out different bits.
So it's basically a living thing.
Every time you're running a different thing, right?
So that's the state of the art in environmental omics, environmental biodiversity is a kind of mixture of partially hacked scripts. Yeah, it's definitely reflecting the field. Actually, so we were to a biodiversity meeting this time last year. There were, and we had a workshop for what is good software, and it was in parallel with 5 or 6 other workshops at a lunchtime on the 4th day. So you can imagine we didn't expect anybody to come to this. 120 people turned up, right? That was a shock. And they were all young, and they were all people who do development, they all write code, right? And we broke them into groups. And in my group, I said, right, you know, one person in my group had heard of versions, heard of it, and one other group said that they'd once heard something about parameterization. Woo! And these were the leading bioinformatician, developers of biodiversity scripting. This is what, you know, they were the young driving, that's what they did. And that is state of the art, so it's not surprising. Well, it's actually kind of the antithesis of what they were saying. It's hacking. They're really programming all the time, really low level. Lower level than we would want to do it, actually. And so it's kind of, on the one hand, you've got grubby scripting, and on the other hand, you've got, I don't want to lay my hand upon the computer. And so it's kind of, and workflows sit in the middle, and that neither loved by either.
At the Pro Biosphere meeting, Alex Howard had to have a special sort of side session to teach people about Git. How to do it.
Yeah, the person who's heard of versioning had heard of a thing called Git. That's what they were very excited about. So this is why we run software carpentry. This is why software carpentry.
In my experience, it's usually from one side. They don't want to touch the computer too much. They want to only those parameters that they understand, like the temperature, the log. You know, there's no restriction or something. They're happy to see the pretty workflow boxes, but whenever they hit run, you know, this is why one of the things I used to do. I used to do for other workflows, put these constant parameters already in there. Then I realized, oh, actually, they want to change those inputs, and so it asks them every time, you know, just to put in the temperature range that they want to do or something like that. And that's all they want to do, at least in the beginning. And then they get accustomed to changing and running the workflow about 100 times, but then they might actually go in to change a different kind of parameter. You know, they start getting used to it, but that's what you gotta.
So you kind of have a dashboard with some dials on it.
Yeah.
So you push that up, run it again, ooh, see what the difference was. Push that up, run it again, see what the difference was. That's it's kind of hacking. Hacking through the exploration of the and our biodiversity runs. That's exactly what they do.
So they call evolution programming.
It's exactly what they do. We have these workflows that we carefully develop.
No, why did you just say,
With all
we
these
need a parameter for
parameters.
that? We don't know what it is.
And
Let's
then
just
you
fight for it.
and then you produce, and you do this 600 times, and then you look at the results. That's what happens.
The interesting thing is if they do want to make changes, because they know usually the lower level program, there's like an application that's running on this server that's over there. They'll SSH into that server and change or tweak the actual program itself just to verify, is it really giving me the results, you know, or something
That's
like
a
that.
strong story, yeah. I can safely say our biodiversity people don't do that. But the strongest thought, and if you're a particle physicist, good grief, you know, you're a particle physicist, you're just going to write it in assembler. So it's, you know, it's just completely different world. I'm kind of surprised it gave us kind of insight into the feed rate system is quite anyway. I think it's much more complicated.
This system is a more complicated. I think from what I understand about it, that I know a little bit of EVO people had gotten involved with it, that it was, you know, because you're trying to almost merge 3 or 4 different workflow platforms together, you know, and it's going to get technical no matter how you go.
That's serious engineering. I mean, you imagine trying to merge, you know, develop with 3, you know, new developers. I'm not a developer, I just write what grants and get people money.
It's just that we say that this house on Java, Ruby, and .NET thrown together. You're going to spend most of your time making data types and web services, so who knows?
Not big when we weren't. Yeah, exactly. No, you're absolutely right. And it's going to kind of all be a bit shaky, isn't it? It's a bit like taking 3 bits of a car and welding them together to say, I built a Mercedes. No, you haven't. You've got 3 bits of a car, you weld them together. It's going to fall to pieces when you drive it.
How they build cars, all the parts are the same, all different cars. But
Not if it's a cut and, what's it called, Alan? Cut and shunt?
Cut and shunt, yeah.
Yeah, cut and shunt. It's different.
It's basically like the BMW and a Sport, basically it's the same car with a different shell and a different engine.
Yeah,
Even if it's works, it's not elegant.
it's not open. Well, there's a thing called cut and shunt in the UK, which is cut and shunt is you take two cars, one of which was smashed in at the back, one of which was smashed in at the front, right? And they've now been ripped off, right? So you cut them in half, right? And then you weld them together, spray a bit, ta-da, new car.
Wow, I'm surprised you can do that.
And it's illegal, obviously it's illegal because it's dangerous. And these things,
It's really problem because there's so many technologies. For example, Java is usually used in research because it's free, like it was free now. Oracle wasn't, I know what's happened.
no, that's still great.
The heck is where Java moved. Because, for example, Java is for real code. Java was supposed to do some hacky things initially, but now it's latest Java changes. For example, I remember 3 years ago.
That's why I see people are moving from Java to R.
Well, it's something different, ours is a bit different.
R actually is not programming language.
No, it's
mathematical method.
What makes R, basically it is a workflow language really, right? Because you look at most of those R scripts, they're basically just workflows around most of the statistical functions.
They are.
Those are programmed a
They
bit
are.
more properly, right?
Yeah.
That's all you do, is just tie these
Trying to
together
tie
and you get
them
some lovely graphs and some predictions coming out of it.
That's exactly it. And what we're effectively doing, quite a few of our population modeling workflows, developments, is effectively operating as a workflow engine operating the R scripts.
But I think that the interesting thing is how you will have the same situation as the main scientist against computer scientists is in R problem, is that now you should really have a statistician on board as well.
Yeah.
Because maybe the statistics you're doing in your R script doesn't make sense,
Well,
yeah,
because you're mixing together two
But
things.
it is a part of computer science.
I think mathematicians might, actually no, mathematicians won't argue about statistics because no mathematician really cares about statistics. You can't do research in statistics. So this is why I always find it interesting that the data science community says, oh, let's bring in all these mathematicians. But statisticians don't live in mathematics,
Computer
they live
science
in
was
biology.
born from maths. I don't know, it was obligatory, some math, operations, dynamic programming.
Yeah, this is, yeah, so that sort of thing is in computer science, but also, and it's also in physics, and it's also in chemistry, it's all these other places. UCL, if you go to UCL, I can't speak on that way, in Spain, but if you want to find the statisticians in UCL, you go to the astronomy department, or the physics department, or the biology department. You don't go to the maths department. Maths department's full of wild and wacky logicians who are doing wild and wacky movie mathematics, which isn't useful to anybody. And because there's no research in statistics. There's no fundamental research, no novel papers. How can you publish a novel paper in statistics? It's very difficult to do that, right? Or possibly impossible. Whereas you can do, so I don't know, so top of n-dimensional modeling theory, I don't know what it is.
New test, all the things.
Yeah.
There's always a new test. Like G-test.
It's all the standard stuff, right? But that stuff is always held in, it's never taught in maths departments.
I don't remember the name of that book, but the C algorithm.
Yeah.
The reference for C algorithm, I don't remember that.
I can sign up
Sorry?
I can sign up for a live presentation.
Yeah, we can do one tomorrow, yeah.
Yeah, I can just, I already have something.
Very brilliant, yeah, that would be nice, yeah.
Modularity and
Statistics
you know,
is done
what's
in
the,
social
unit.
science.
Yeah, that's brilliant. So you're here tomorrow, right?
Yeah,
All
I'm
day or?
tomorrow, but I mean, I'm not gonna stay really late.
Okay, so let's see, because
Things at 4:06.
6:15.
And
So I will read directly from people. I don't know how long it's
And
6:45.
this kind of.
So 5:45, you want to be there. Take a train then.
No, we can take a cab.
You're going to take a taxi. It will take longer in that taxi at 5 o'clock. 4:30 or so, you would have to 4, you would have to leave at 4, definitely, right? So we can start with you if you want, because we have the session at 1
Yeah,
o'clock.
I'll probably quick. I can just give a real life example.
Yeah, we'll do it in there.
Okay, thank you very much.
Yeah?
Thanks.
You have a title?
The disciplines where you want things to be delivered, and not the
Yes.
disciplines where you do the fundamental research. So,
Yeah, it doesn't matter, we could see.
I don't know, modular workflow
You
design
normally use
for
software
procurement.
engineers,
And
they're not computer science researchers.
okay,
Computer science researchers are something else, okay, yeah, so these guys, they're all software engineers working for me, and they're computer science researchers.
It's different because that's an engineering, because I always say I'm an engineer because I want to start working.
Exactly, exactly. That's why you can do exactly.
Right there now?
yes, yeah, that's mine.
Exactly.
Okay, and then-
Only departments, school, only research.
Modularity? No.
Yeah, modular workflow design for
That has
for
software
the analysis of
engineers is my,
procurement data.
all the others have researchers.
Okay.
I don't want
Thank you very
some,
much.
I know, glass breach, I need the breach.
Yeah, exactly. So the difference between computer science research and software engineering, we always say is computer science doesn't work and software engineering does. That's the definition of it. So, and in fact, if the computer science does work, then you couldn't be going to venturous enough.
No, it just
in your
becomes
research.
engineering, it's important to
Yeah.
engineering.
Yeah, exactly. On this bombshell.
Yeah.
I think we should have a little break, then we can.
And I also want to.
We'll walk down to the restaurant, so that we said 6:30, we said?
Yes.
Yes, so I guess we leave here just before 6.
Is that just on this way?
We get ready at 6 to leave at 6:10.
Yeah, I need to go and see my student.
We're checking the hotel first.
Okay, where's your hotel?
It's this one, which I guess is only about 10 minutes that way, so I'll just quickly check in. And meet you guys at the restaurant. Well,
Okay.
I'm sort of picturing that way, I don't know, but I'm gonna turn around.
Yeah? You know where it is.
Union, right? Across the.
It's opposite the students' union next to the.
Oh, why not?
Yeah, if you walk out the Kilburn building, I'm thinking, if this is basically to the right, then the crowbar will be to the left.
Yeah.
Yes, Crowbar is slightly
Further
further
down.
Further down, it is,
Further up.
away from the city.
It's only a few minutes.
Was it 6?
Oh,
Can we like take yours
You can stay here unless you pop to the hotel. We can track it on the way back anyway. Which hotel are you in? It's to the south, down on the right, the main road. There.
So, you're gonna,
Right, you in? Okay, it's just around the corner. Right?
But it's not on the way to the restaurant.
No, it's the opposite direction.
all right, okay. No,
we don't leave our stuff here, right?
Yes.
We go on, yeah.
Yeah, I can breathe, yeah. I'll see you there.
And then
On the side that
we share.
You know where it is, the crowbar?
Are you?
No, but it sounds like it's paper up here.
It's the main hotel.
Yeah, Monday sent an email for another.
Yeah.
Are you going to?
You can do it.
What?
A lot of meetings I want to see.
Yes.
Yeah, I'm enthusiastic because it's my first year. Maybe I'll ask first try this.
I'm hearing everything the same.
Okay, it's your fault if the IT company.
But it doesn't actually say, it's not that very.
So it's still sales?
Shall we go to the
It doesn't matter for me, we can do that if you want to leave it, yeah.
No,
doing business?
Yeah, okay, I'm looking for
15 minutes.
Yeah, it's sitting here, okay, drink some water. Get some real fresh air if you like.
Yeah.
I'm going out, I'll come back.
Okay.
That's fine, but that's.
Where do you go?
You need to find the thing, and then.
You can go out there. You can go out there. Really? I'm not kidding. I'm not kidding.
Yeah, I know.
Doesn't say nothing connecting, but it's
Do you want
the
to
broker.
It's early days, so all of these things.
So we have an hour, now it's.
Yeah, we're leaving in, well, we'll leave from here in half an hour and we'll just hang out here.
No, it's not like just come back to the hotel and come back here again, it's something like 1 hour. No, 40 minutes.
Yeah, but we won't be there at 6:30, we'll be at the restaurant at 6:30.
6:30, but it's 7.
Huh?
1 hour.
Yeah, so we're at the restaurant at 6:30.
Well, no, I don't.
About 5 minutes further south.
I know, but I'm thinking to go to the hotel, that it's 15 minutes. Like 20 minutes there.
It's up to you what you want to do, you can just hang out there and.
That's probably prefer in hotel, I think.
Okay, that's good, so I'll see you, are you coming back here then?
No, I know where it is.
You know where it is.
Yesterday.
You were there yesterday?
Yeah.
Okay, I'll see you at the Crowbar then.
It was very productive. Very nice workshop so far.
Huh? Good, thank you.